All right, this lesson is a little bit different. You can see just by looking at several of the first problems that we have a lot of different variables going on. These are called literal equations. And some students really like this lesson because there's not all of the computation that we have in some of the other solving equation lessons. But a lot of people are scared by this lesson because of all the variables that they see. I just need you to make sure you are aware that all the rules you learned for solving equations still apply. So I'm not throwing new rules at you. They're the same rules. It looks funky because of all the letters. Okay, so this first problem is asking us to solve for h. So I'm going to look on the side of the equals where I see the h, and all of these things are smushed together. So I've told you before, whatever's smushed with the variable, you save that for last and get rid of whatever else is on that side. The thing is, nothing else is on that side. So I have nothing to add or subtract away. So my goal to get h by itself is to get rid of the b and the 1/2. Well, the 1/2 is the thing that makes this look the ugliest. So I want to get rid of that first. So do you remember how when the fractions multiply with the variables, you get rid of it by multiplying by the reciprocal? So let's flip it over. So let's multiply this side by 2/1, and let's multiply this side by 2/1. I'm just not going to put over 1 because the a is not in fraction form. Okay, so on the right side, the 2's and 1's on the diagonal get to cancel out. Shoop, shoop. All I'm left with is bh. Bring down your equals. And then 2 times a is just 2a. Okay, now my goal is to get h by itself. So let's just say I had the equation 8 equals 4h. If I was to get h by itself, how would I get rid of this 4? I would divide both sides by 4 because that's how you undo multiplication. Okay, well, I'm going to do the same thing here. To get h by itself, this smush, this multiplication, I'm going to get rid of it by dividing by what I don't want. Up here, the 4 I made up, I didn't want it, so I divided by it. In this problem, I don't want the b, so I'm going to divide both sides by b. And then b divided by b is 1, so that's just gone. So all I have left is h. I can't actually divide this because these aren't the same letters, so it's just 2a over b. And that's my answer, and I'm done. So, not a lot of calculations, but it might have scared some of you. So, just remember, get rid of fractions by multiplying by the reciprocal. So that's not a new rule. Get rid of multiplication with division. And that was it. That's all I did in that problem. All right, let's look at number 2. My goal is to get the w by itself. So I'm going to look on the side of the equals where the w is. And I see that the L and the H are smushed with it. So there's nothing outside of that to add or subtract away. So to get rid of the smush, to get rid of the multiplication, I divide. And I'm going to divide by what I don't want. I don't want the L, and I don't want the H. And whatever I divide one side by, I have to divide the other side by. So on this side, L divided by L is 1, shoop. H divided by H is 1, shoop. All I'm left with is W. On this side, I can't divide these because none of these are the same letter, so I just recopy. V divided by LH. And that's my answer. And I'm done. So this problem, it involved the rule to get rid of multiplication, you divide. And that's what I did here too. To get rid of multiplication, you divide. I also had the rule of to get rid of a fraction, multiply by the reciprocal. So these are all the same rules you're used to. They just look, a little confusing because of all the variables. Okay, let's look at number 3. I'm trying to solve for h. So let's look on the side of the equals where the h is. And everything is smushed with that h. And there's nothing outside to add or subtract away. So I'm going to divide. To undo multiplication, I divide. I don't want the 2. I don't want the pi. I don't want the r. Because I'm trying to get h by itself, so those are the 3 things I want gone. And if I divide the right side by 2 pi r, I'm going to divide the left side by 2 pi r. And then 2 divided by 2 is 1. Shoop. Pi divided by pi is 1. Shoop. R divided by r is 1. Shoop. All I'm left with is h. And then I can't actually divide any of this mess, so I'm going to leave it. S divided by 2 pi r. And that's my answer. What do you think? The first 3 weren't so bad. Okay. Now, this next one should look like something you've seen in the past. Just the whole format of the equation. So my goal is to solve for y. So I'm going to look on the side of the equation where my y is, and I have something smushed against it and something outside of it. So whatever's smushed against my variable, I'm going to save that for last. This time, because I have something outside of it, like here I had nothing outside of what was smushed with my variable. But here, if you have something outside of what's smushed with your variable, you want to zero it out. So you have to add or subtract to make it go away. So to make this positive 2x go away, I have to subtract it. And 2x minus 2x is 0. So shoop, that's gone. I'm going to bring down my negative 5y. I'm going to bring down my equals. And then this side, I can't actually subtract these because this has an x and this doesn't, so they're not like terms. So I'm just going to recopy it. This is a positive 15, and this is a minus 2x. So all I did was I brought the 15 down and I brought the minus 2x down. I didn't do any math, I just rewrote things. Okay, now to get y by itself, I have to get rid of the negative 5. And these are smushed, so they're multiplied. So to undo multiplication, I divide. So I'm going to divide both sides by negative 5. And negative 5 divided by negative 5 is a positive 1. So all I have left is 1y or y. Now this side, I'm going to reduce. So when you have both of these divided by negative 5, it means the 15 is divided by the negative 5 and the negative 2x is divided by the negative 5. So first, let's do the 15. What's 15 divided by negative 5? Negative 3. And now let's do the negative 2 divided by negative 5. A negative divided by a negative makes a positive, and then 2 divided by 5 doesn't reduce, so it just stays 2/5, and don't forget to recopy the x. Now, a lot of times, you'll see this written with the positive 2/5 x in the front and this minus 3 in the back. This, my friends, is called slope-intercept form. So I know that is a name from your past, slope-intercept form. Y equals mx plus b. When you go to graph lines, y equals mx plus b, slope-intercept form is very important. And I don't care if you write it like this or you write it like this. Later, I'll want it to look like this, but for right now, this way is fine. Let's try another one like that. Okay, number 5. My goal again is to get y by itself. So I'm going to look on the side of the equals where my y is, and I'm going to circle what's smushed with it because I'm going to save that for last. And since there's something outside of it, I have to zero it out. So I have to add or subtract. So to move a minus 4x, I have to add it in order to zero it. That way negative 4x plus 4x is 0. Shoop. Bring down the positive 2y. Bring down the equals. And then I can't actually add these because this has an x and this doesn't. So I recopy. I bring down the minus 18. And I bring down the positive 4x. So no math, just drop it down, drop it down. Drop, drop. Okay, now to get y by itself, I need to get rid of the 2. So I'm undoing multiplication here. So I'm going to divide both sides by 2. So 2 divided by 2 is 1. So all I have left is 1y or y. And then this is all divided by 2. So the negative 18 is divided by the 2, and the 4x is divided by the 2. So let's start with negative 18. What's negative 18 divided by 2? Negative 9. And then how about positive 4 divided by 2? a positive 2. Don't forget the little x. So you can either write it like that, or you can have it flipped, where you put the positive 2x first and the minus 9 in the back. Either way, they both mean the same thing. Okay, what'd you think about those? So this was kind of like our two-step equation, where whatever was smushed with the variable, you save that for last, and you get rid of what's next to it by adding it or subtracting it away. Okay, this problem here, my goal is to solve for x. All right, so I'm going to look on the side of the equals where my x is, and I have something smushed with it and then something subtracted from it. So whatever's smushed with it or divided by it, I save that for last. So I'm going to get rid of what's outside of it by zeroing it out. So to get rid of subtraction, I know I add. So I'm going to add c to both sides. Just like if I had 2x minus 4 equals 8. Whatever's smushed with the variable, I save for last, and I get rid of subtraction of 4 by adding 4. I just made up a problem over here that's supposed to look like this one. So I'm just trying to show you that whatever is outside of what's smushed with your variable, you get rid of subtraction with addition. So that's what I did. I got rid of subtraction with addition. So just like this makes 0, negative c plus c makes 0. Shoop. And then your ax would come down, your equals would come down. Just like in my made up problem, my 2x would come down, my equals would come down. Now the difference in this problem versus this one is I can actually add these numbers together. 8 plus 4 is 12. Whereas over here, I can't add these together because they're not the same variable. So I just recopy it. The d goes first and then plus c. So I just drop it down. I drop down the d and I drop down the plus c. And then if this was my problem, to get x by itself, I'd undo this multiplication with division. So I would divide both sides by 2. Same thing here. If I want to get x by itself, I'm going to undo this multiplication with division. So I'm going to divide both sides by a, because that's what I don't want. And then just like 2 divided by 2 makes 1, so all you're left with is x. A divided by a makes 1, so all I'm left with is x. Now in this problem, I can actually divide these. 12 divided by 2 is 6. In this problem, these are both divided by a. So can we divide d by a? Nope, they're not the same letter. Can we divide c by a? Nope, they're not the same letter. So since I can't divide either one of these by a, I'm just going to recopy it. D plus c over a. And that's my answer. So if I was to give you this problem over here, I think most of you would be very successful with it. Well, this problem is exactly the same. It's just letters instead of numbers. So just remember, to get rid of subtraction, you add. That's what I did. I got rid of subtraction by adding. And to get rid of multiplication, you divide. And that's what I did. I got rid of multiplication by dividing. Okay, now this next problem. We've seen something like this before, and we turned it into what was called a proportion. My goal is to get x by itself. Okay, so I'm going to pop this y over a 1, creating, remember, what's called a proportion. A proportion is when you have one fraction, an equal sign, and one fraction. And whenever you have a proportion, you can solve by cross multiplying. So Mr. Butterfly, I'm going to take 1 times 4 minus 2x, and that's just 4 minus 2x. And then I'm going to multiply this other diagonal, t times y. Now we haven't talked about this before. When you multiply letters together, you write them alphabetically. So t times y would be ty, and that's because t comes before y in the alphabet. So instead of writing yt, I write ty. So when you multiply two letters together, you keep them smushed but put them alphabetically. If you add two letters together, you don't have to write them alphabetically. So I didn't have to write c plus d. So if you're just adding them, you don't put them alphabetical. But if you're multiplying them, you do put them alphabetical. Okay, now my goal is to solve for x. So I have something smushed against it, so I'm going to save that for last. And the guy that's outside of that, remember, we're going to zero him out. So this is a positive 4 because there's nothing to the left of it. So to get rid of a positive 4, we have to do the opposite and subtract. So 4 minus 4 is 0. Shoop. Bring down your minus 2x. Bring down your equals. And then you can't subtract these because this has a ty and this does not have a ty. So you just recopy. Bring down the ty and bring down the minus 4. Not doing any math, just dropping it, dropping it. Okay, now to get x by itself, how do you think we'll get rid of the negative 2? We'll divide. This is smush, this is multiplication. So we're going to divide both sides by negative 2. So negative 2 divided by negative 2 is 1. So all I'm left with is x. Now on this side, these are both divided by negative 2. Just like up here, these were both divided by 2. Okay, so first I'm going to divide ty by negative 2 and then negative 4 by negative 2. So let's look. Can I divide ty by negative 2? I can't. But can I divide negative 4 by negative 2? I can. So I'm not actually going to leave it like this. So since ty over negative 2 doesn't reduce, I'm just going to recopy it. Ty over negative 2. The only thing is, instead of putting the negative in the denominator, I'm going to put it up in the numerator. It means the same thing, but mathematically this looks better. Now, what's negative 4 divided by negative 2? A positive 2. And that's my answer. May not look pretty, but that's it. Okay, this lesson takes some practice. So I know that some people really struggle with this and some people really like it. All right, let's look at this guy. This one we are trying to solve for w. Okay, now I notice that I have w's on both sides of the equals, and I can't have that. I can only have one w if that's what I'm trying to solve for. So I need to get these w's to the same side. So either move this guy over here or move the 4w over here. Remember, I like to move the smaller one, so I'm going to make him go completely away. So to zero it out, to get rid of subtraction of w, I do the opposite and I add w. So negative w plus w is 0. Shoop. Bring down that 5u. Bring down that equals. Bring down that u. And then 4w plus w, we can actually add those. Those are like terms. So 4w plus w, that makes 5w. Remember, there's a 1 in front of that w that you don't see. So 4 plus 1 is 5. Okay, so my goal is to get the w by itself. So this that's smushed with it, I save that for last. So the guy that's outside of it, you want to zero it away. So either add or subtract. So to get rid of a positive u, we're going to do the opposite and subtract it. That way u minus u is 0. The 5w comes down. The equals comes down. Now, can you actually subtract these? You can. They're like terms. They both have u's. So remember, there's a 1 here that you don't see. So 5u minus 1u is 4u. Okay, and then I'm still trying to get w by itself, so how can I get rid of the 5? Divide. These are smushed, so they're multiplied. So I'm going to divide both sides by 5. And then that makes 1w, or w. And then if I could divide 4 by 5 or reduce 4/5, I would, but I can't. So that's the answer. So 4u over 5. Ooh, barely fit in there. 4u over 5. Okay, so all of our solving equation skills that you already know, we're just using them on the same lesson. Just, it looks weird. All right, this next one. Don't let this frighten you. All right, we're trying to solve for x. So let's find x. I only have one x. There's not one here and here, so I don't have to move anybody over. So remember, whatever's smushed with your variable or divided by it, we save that for last. So whatever's outside of it, we want to zero that away. So how do you think I would do that? I would add it. To get rid of subtraction of 2b, I do the opposite and add 2b. That way, negative 2b plus 2b is 0. Shoop. This c over dx, it just comes down. And then the right side, do you think you can add those? You can't. You can only add things if they're like terms. An m with an m, a b with a b, an m squared with an m squared. So you can't do anything, so you just recopy. Bring down the positive m, bring down the positive 2b. Okay, so now to get x by itself, do you remember how we get rid of those fractions that are smushed with the variable? We multiply by the reciprocal. So I'm going to multiply this side by d over c, and I'm going to multiply this side by d over c. But I've got two different terms over here, so I need to put parentheses around it to get the whole thing multiplied by d over c. Okay, so remember when you multiply fractions, if you have the same thing on the diagonal, they get to cancel out. So the d's, shoop, the c's, shoop, shoop, shoop. All you're left with is x. Okay, and then I'm going to distribute the d over c. So remember, this is understood to be over 1, and so is this guy. Everything is understood to be over a positive 1. So when I multiply these, remember you multiply straight across, straight across. So d times m is just dm, put your fraction bar, and c times 1 is just c. Now let's multiply the d over c times the 2b. So when I multiply d times 2b, that would be a positive 2bd. Remember, you put your letters alphabetical. And then when I multiply the denominators, c times 1, that's just c. And that's my answer. This one might have been a little frightening for you, and I get that. So remember, whatever's smushed with the variable, you save that for last and get rid of the guy outside of that by adding it or subtracting it away. And then remember, to get rid of a fraction, you multiply by the reciprocal. It's just distributing that fraction might have been what frightened you a little bit. So d times m is just dm, because you write letters alphabetical when you multiply, and c times 1 was just c. And then d times 2b is just 2bd, and c times 1 is c. Okay, and that's all for this lesson. Smiley face.